Should be live right now. Go.
Okay, so it's your boy, Professor Will. I'm going to ask you another Fortnite Let's Play. Today we're going to be talking about insulators, lightning, conduction, induction, electrical forces versus gravity, circuit versus static, and electroscope. Not sure what electroscope is, but we're just going to go with it, okay? So an insulator, that's a thing that insulates. I can write, I promise. So when you have an insulator, some great examples of these are coolers, wire padding stuff. I'm not sure what that's called. It's the plastic stuff on it. So we're going to call that wire padding. Basically, the importance of this is that electricity cannot flow through it. So a great example of this is you can, when you have a wire, obviously this is a wire. I know it's beautiful. I'm an art major. I studied with Shakespeare. Anyways, so when you have this padding around it, if you always notice wires are never exposed, the copper is exposed, that's because the electricity tries to go out, and if you were to, say, touch it, you won't feel a thing. But if you touch the wire, you would get an electrical shock. So that's basically the point of insulators, is to not have that. So, I don't know how to erase this. Yeah, technical difficulties. Okay, there you go. So, next we're talking about conductors. These are basically the opposite of insulators. And some examples of this would be the copper part of the wire. And metal. Just metal in general are conductors. Some other examples would basically just be metal. So, metals. So when you have metals, when electricity goes through them, it actually is basically doesn't lose its voltage or anything. It continues on. So if you touch a plain wire, this is a wire. I know it's great. If you touch this, this is going to shock you because it can carry an electric current. That's what makes it a conductor. And then the page thing. Yeah, there we go. Okay. See? I'm good at this. So lightning's pretty cool. You can also call it lightning if you're lit. Yeah, if you're lit. That's the thing. So lightning, what happens with lightning is it's actually created from static electricity. So, basically what happens is when you have, let's get some blue up in this joint, if I can click it. Okay, so when you have all these raindrops in the sky, sometimes when they're in clouds, basically, is generally when this happens, so we'll make this a cloud, these water particles are very, very fast, and that's because they're in a gaseous state. So gas is generally faster movement when it comes to molecules. So these little water molecules are jittering around and go in all kinds of directions. And what happens is that these water molecules will bump into each other and rub and cause static electricity. And basically what that is a buildup of charges, and what eventually happens is that so much of this is built up through them rubbing into each other that you get a big old lightning thing going on, you know, like this. So, that was great drawing. So, that's what lightning is created by. Is there anything you want to mention besides that about static electricity?
What's being built up when the particles hit each other? What part of the atom?
What part of the atom? Oh, yes, the electrons are being built up. And that's what that is. So that's what static electricity is. Okay, next we have electrical forces versus gravity. Basically, electrical forces are much stronger. Gravity is kind of a passive force. So we're going to do a little kind of Venn diagram looking thing here. So, and then we've got gravity. So we've got Gravity is a lot weaker. Electrical forces are caused by electrons, obviously, because that's what electricity is. And then gravity is caused by mass. So those are some basic differences. Electrical forces obviously can be harnessed for things like devices. So anything powered by electricity is obviously powered by electrical force. And when it comes to gravity, it's a little harder, but it can be harnessed for things like dropping, and harnessed for movement is a great example. So generally, it's a great example is that you're more likely to go downhill when it comes to, if you're trying to move something, you want to move it downhill because it's going to be a lot easier because you're not fighting against gravity. In fact, gravity is helping you. Okay, and then the last thing is circuit versus static. So circuit is basically, it's the flow of electrons. So there's lots of movement when it comes to this. And when it comes to static electricity, it's actually buildup rather than flow. So this is part of the reason that static electricity is generally considered useless, because it is not consistent and it can't be recycled. Whereas circuits can be harnessed. It's kind of a weird verb, but /used. And also can be recycled. That was an interesting E. Now, there's two kinds of circuits, and that would be series and parallel. And there goes my 7th bell. I think that's it. I'm going to be gone now, so that's cool. Stop.